So the concept of radioactive decay ties into half-lives, which you've probably talked about in other classes. So when a sample is radioactively decaying, the half-life is the period of time that it takes for half of that sample to decay. This works really nicely mathematically to give us this kind of nice decay curve, which you've probably seen in your math classes. So if we were to start, for example, with 32 carbon atoms, and I know it's kind of a ridiculous number to start with, but if those 32 carbon atoms were allowed to go through one half-life, we would then have 16 remaining. After another half-life right here, we'd then go down to 8, and we'd end up down at 4, 2. If we continued, we'd end up down to 1 carbon atom. What's important to remember, however, though, is the mathematical nature of this. We never actually have it disappear. So if we started with our 32 carbon atoms, after one half-life, we went down to 16. So that's 50% of the original, or 1/2 of the original. If we continue to go through half-lives, we then go down to 8, and it's 25% of our original. Finally, we go down to 4, 12.5%. After 4 half-lives, we'd be down to 2, 6.25% of the original sample. After 5 half-lives, we'd go down to 1, 3.125% of the original sample. Now, if we continue to go from here, we would never end up with 0. So after 6 half-lives, we would actually have 0.5 of a carbon. We would never actually go to 0. So, and we're actually going to show this in the Hetzanium lab. Also, we'll just do a little simulation of this. To solve half-life problems, you're going to need reference table N. Radon-222 is a carcinogenic house pollutant. If your basement was found to contain 20 grams of radon-222, how many grams would remain after about 19 days? So you first go to reference table M, and you find radon-222 with its half-life of 3.823 days. So to figure out the number of half-lives that are going to occur, we're going to do our total time over half-life length. In other words, we're going to do 19 days over 3.823 days. Now, when we divide this, keep in mind, it does say about, okay? So you can actually have decimal half-lives, and you can deal with those in certain problems. You're going to notice this comes out to about 4.9, so we round this to about 5 half-lives, and that's all that we really need to do in this particular unit. Then I have something I call an arrow diagram. So I say, okay, what's my starting amount, which is my 20 grams? And then I just chop this and count my half-lives. So if I chop it 1 time, it goes down to 10 grams. If I chop it 2 times, it goes down to 5 grams. If I chop it 3 times, it goes down to 2.5 grams. If I chop it 4 times, it goes down to 1.25 grams. And if I finally chop it a 5th time, it's going to go down to 0.625 grams remaining. How long will it take for 400 grams of P32 to decay to 50 grams? So I first go and find P32 with a half-life of 14.28 days. So the approach on each of these is not exactly the same. It kind of depends on what you're given. So I'm going to start by saying, if I started with 400 grams, how many half-lives would it take for me to get to 50? So if I chop this in half 1 time, it's going to get me down to 200 grams. 2 times, it's going to get me down to 100 grams. And if I chop it in half a 3rd time, that's what gets me down to 50 grams. So I had to go through 3 half-lives. So since each half-life is 14.28 days, I'm going to multiply 3 times 14.28, and I get 42.84 days. 12% of a K42 sample will remain after 49.6 hours. So you're going to find potassium 42, which is 12.36 hours. And we're going to determine how many half-lives will pass. So our number of half-lives is going to be 49.6 hours over 12.36 hours. So when we divide these, we get just about 4.01, close enough. So now we're going to do a arrow diagram, but this time we're going to do it with percents. So we started with 100%. And if we chop this one time, we get down to 50%. If we chop this 2 times, we get down to 25%. If we chop it 3 times, 12.5%. And then our 4th chop will get us down to 6.25% of the original sample. Sometimes these are asked with fractions, so I will go through this with fractions also. So if you have the whole number 1 half-life gets you to let's do this fractionally. If you chop it again, we'll go down to 1/4, 3rd time, 1/8, 4th time, 1/16. Again, I'm not a huge fan of fractions, but a lot of the time these questions do ask for fractions. So a couple of problems here for you to try. You can pause them and I'll pop the answers up with the work. So in the first one, your first step is to figure out that you have 3 half-lives, and then you just chop that in half, 20 to 10, 5 to 2.5. Your second one, you're starting with 100 grams. To decay that down to 25 would be 2 half-lives. You multiply that by the length of the half-life to get 11,430. The last one kind of tricks people up a little bit because this total time went by and then they told you this was actually what you had at the end. So what you're actually doing is figuring out that you have 3 half-lives that have passed already. So then you say, okay, I ended up with 35. Before that half-life, I had 70. Before that half-life, I had 140. And then before that half-life, I had 280. So it's kind of looking at it a little bit backwards.